You see the dreaded memory exhausted error on your WordPress site. You search for a solution, find the standard advice to paste a quick code snippet into your wp-config.php file, and hit save. But when you reload your site, it still crashes. That happens because software commands cannot override physical hardware limits. When multiple visitors hit your site at once, the physical server buckles under the concurrent load, regardless of what you wrote in your configuration files. Modern shared hosting environments utilize 3 separate stacked memory ceilings to control how much RAM your site can actually access. We are going to pinpoint exactly which of these 3 ceilings is blocking your site. Then we will apply the correct fix at the exact layer causing the problem, whether that requires a WordPress change, a quick adjustment in cPanel, or a hosting container upgrade. You have to map the actual server architecture you are running on. Without knowing exactly where these physical boundaries are, you are just guessing at fixes while your site remains vulnerable to outages. To find your current ceiling, we start right inside the WordPress dashboard. Navigate to Tools, select Site Health, click the Info tab, and scroll down to the Server section. Look for the row labeled PHP Memory Limit. This number represents the specific limit PHP is currently enforcing on the server. It reflects the real-time allowance granted by the host, regardless of the value requested in your site's configuration files. To test if WordPress itself is the bottleneck, open your cPanel file manager, edit your wp-config.php file, and add the WP memory limit definition, setting it to 256 M. Save the file and refresh your site health page. Check that exact same row to see if the limit has successfully increased to 256 M. If the number remains stuck at 40 megabytes, your edit didn't fail. It means a higher-level server limit is actively blocking your request. This is Layer 1. Your wp-config file acts purely as a request to the server to allocate more memory. It is not an authoritative override, and the server will ignore it if a stricter ceiling is in place. That stricter ceiling is Layer 2, the PHP memory limit. This is a hard cap set by your server's PHP configuration that intercepts and denies any WordPress request trying to exceed it. You might read guides telling you to add code to your .htaccess file. Do not do this. If your host uses modern Lightspeed servers, pasting PHP memory values into an htaccess file will immediately trigger a 500 internal server error and take down your site. Instead, log into cPanel's MultiPHP INI Editor. Select your PHP version, locate the memory limit row, and change the value to 512 M. Click Save at the bottom of the editor to apply the setting server-wide. Go back to your WordPress dashboard and refresh the site health page one more time. You should now see the PHP memory limit row displaying that full 512 M allowance. Bypassing the PHP ceiling gives individual scripts the room they need to function. But this only solves the problem for a single process running in isolation. If 5 users try to check out on your WooCommerce store at the exact same moment, your site is still vulnerable to crashing. This leads to the most confusing scenario for site owners. Your site health page proudly displays a 512 M limit, yet your site continuously throws 503 errors during busy WooCommerce checkouts or large media uploads. The final barrier is Layer 3, the LVE PMEM container limit. This dictates the maximum physical RAM your entire hosting account can use. When simultaneous processes run, their memory usage stacks. Once that combined load hits the DOM, the server forces a 503 error. Because this limit is enforced at the operating system level, there is no file you can edit or cPanel toggle you can switch to bypass it. The only way to resolve a container bottleneck is to upgrade your hosting plan. Moving from a bronze plan with 512 megabytes of PMEM to a silver plan with 1024 megabytes actually expands the physical size of the container. Stable hosting infrastructure requires enough physical headroom to handle your busiest moments. When your container size matches your peak concurrent traffic, your site stays online through the spikes. You now know how to verify your active memory limits inside Site Health, configure the MultiPHP INI Editor, and map exactly where your server's constraints are located. Some hosts refuse to disclose their LVE PMEM limits, forcing you to submit support tickets every time your site crashes. When a host hides their container ceilings, they are hiding the true constraints of their infrastructure. Look for a hosting provider that publishes their PMEM tiers before you buy. Clear, transparent limits ensure that you can scale your plan confidently as your traffic grows. A truly reliable website requires two things working in sync: optimized code and explicit knowledge of the hardware boundaries it operates within. Once you understand the physical limits of your server, you can fix the root cause of every crash.